Okay, so I guess we'll get started. So my name is Mitchell Tilbrook, and we're going to be talking about Kotlin bytecode. This gentleman on screen is Alfred Binet. I hope I got that right. So he was a French psychologist in the early 20th century, and because we're in Paris, we're going to start with the standardized test, which is what he invented. So if you ever hated high school, this is who to blame. So this code here actually doesn't work the way you would expect. And so I probably lost about a day trying to work out what was going on until I started opening up the bytecode. And so we're going to start with solving this problem about working out what is going on in this code here. So if we open it up, we can see that we've got our getters and setters. They look quite nice. So if you've never seen bytecode before, it looks a little bit like Java. And for the most part, I've stripped more of the boring bytecode out. So for most of the presentation, everything's going to look fairly readable, and you're not going to hopefully struggle too much. So if we keep digging in, we go into the constructor. The constructors are marked as init. So if you're using Kotlin, you'll wonder why init is like the thing that you use to kind of get stuff in the constructor. This is possibly why. And we can see here that we're calling our super, and we're also assigning the value we've been passed to the constructor to two fields. We're assigning it to the one which we created the var for, and then we're assigning it to this delegate $$ one. Now, if we go and look into our functions that our interface is asking our class to implement, the delegation is actually referring to the code-generated field. So no matter how many times you reassign that var property, it's never going to change the behavior of this delegated class. And so the only way to really get this to work properly is to pass in an immutable value. So you either just get rid of the var because it doesn't actually work, or just make it a val. So if you don't pass in the var, it's just going to use that code-generated one. And this is because the delegate assumes immutability on its part. So what are some of the things we're going to be looking at? So we're going to be looking at more Kotlin-generated bytecode, and what Kotlin is doing to bring some of these features that we love into a runtime, which technically doesn't support some of them. We're going to look at lambdas, quite a few different ways of actually writing lambdas in Kotlin, and the impact of the different ways in which you can do it. Objects and statics and how they work, and a little bit about the companion object, and the impact of consts. You wouldn't think that consts have a fairly big impact, but it can actually add several methods to your program where you just don't expect them to magically appear. And then finally, if we have time at the end, we're going to look at method scoping and a little glimpse into how coroutines actually work underneath, so what they're actually doing to allow that kind of continuation passing. All right, so let's start with some more simple bytecode. So with the Kotlin, if the primitives, you don't have the lowercase int and the uppercase int. Everything is just int. But the way in which you can tell the difference is if the int is assignable to null, then it has to be the uppercase class integer, because you can't assign null to primitives. So if we go into the bytecode, we can see that this is definitely the case. So the uppercase, the nullable integer is going to be using the class instance, and we've said it's not nullable, it's going to be using the primitive. So string interpolation is probably one of my favorite features in any language. I don't care if it's Kotlin or anything else. Just the ability to be able to kind of express everything in one nice continuous string. But how is it actually working underneath? So if we actually go underneath, we can see that Kotlin's actually generating a string builder for us. So it's going to load our constant string here, which we defined, which is just I equals. And then we're going to append it to our string builder. And then we're going to get our static in this case, because I just declared it in a file, and then append it and call it to string. Now Kotlin will do this append for as many variables as you have in your string. And if you actually look at Java bytecode when you're doing ++++, that's also using string builders, but it's using a string builder for every plus concatenation, whereas Kotlin is just going to use a single string builder. So just to get a bit more of a warm-up, we're just going to look at a class. So in the classes in Kotlin, if you just declare a val, we're just going to get a class with a field. We're just going to get the getter, and again, we've got a constructor down the bottom, which is just going to assign our field here. Now, if you want to reduce your method count a bit, you can actually use the @JVM field on all your properties to assign them so that you don't have to have those getters. Because for the most part, if you have an immutable field, the getter doesn't actually serve any real purpose, and over time the JVM will optimize it out. Hopefully, R8 is meant to do this ahead of time, so that should be pretty interesting as to what R8 is going to do in terms of method count in the future. So definitely look forward to that. Alright, so nulls. So one of the great features about Kotlin is the fact that we can feel confident that we're not going to get null pointer exceptions. And so if we actually look at the bytecode for how this method is implemented, we're going to pass in our string, which we're then going to load. But then you can see Kotlin is loading this constant here. And the reason it's doing that is because Kotlin actually doesn't trust you. It actually doesn't believe you when you say that something won't be null. So every time you pass a non-nullable thing to a function, Kotlin is going to call this static method and check to make sure that the value that you have passed it is truly not null. And so it's going to, when you throw the exception, the string there that it's loaded is used to tell you in the stack trace what it was that it found that wasn't null. So once Kotlin is happy, it's then going to invoke your function. So if you do say that something can be nullable, Kotlin knows that every possible execution path is going to be valid because all the ways in which you're accessing the variable is guaranteed to be in Kotlin. Whereas if something is marked as not nullable, Kotlin can't prove that that value didn't come from Java and that Java wasn't lying to you. So in this case, we're just going to check if it is null, then we're going to jump down to our defaults, pop the value and then return. If it's not, we're then going to invoke our string.length here. So extension functions are a great way in Kotlin to be able to add functions to existing APIs or allow you to kind of chain an API together. So instead of having to call like bundle.putlong, bundle.something else, bundle.something else, you can just use something like apply and then just inside that block get rid of that prefix for the entire thing. And the static, the extension functions are effectively just static functions that Kotlin just swaps the parameter around for you. And so they're fairly simple and trivial in terms of implementation. So for the most part, they just compile out to the public final static functions. You can make private ones, but you end up with like weird accessor methods everywhere. And so again, Kotlin doesn't trust us, so it's going to check that it's null, and then it's just going to invoke the function body for us. So inlineable functions is probably the other quite exciting feature about Kotlin. Like, I find most features about Kotlin exciting, so I'm sorry to keep repeating myself. So in this case, we want to have a before, and then we want to have a middle function and an after. So this is good, like if you want to, if you don't want to use the triad resource and you want to make your own one for whatever reason. So you want to call something before, middle, and after. So in this case, if we actually go and look in the bytecode, we can see that there's actually a implementation of our function which doesn't get inlined. And Kotlin will do this because it maintains complete interoperability with Java. So if you do publish this API somewhere and someone is, a Java user is trying to consume it, Kotlin will publish it in such a way that they can still be able to call your function in the same kind of behavioral context that you would expect to see in Kotlin. Now, if you're not using any Java and calling this function, it'll probably get stripped out by ProGuard. So in that case, this function invoke here won't actually be used. And so if we call our Kotlin function in front Kotlin, it's a regular function, then it's just going to take the body of the function and then do the substitution for us. All right, so now let's look at Kotlin collections. So unfortunately, the Kotlin collection is not as enormous as this Hello Kitty collection, which is actually the Guinness World Record holder here. So if we look at, so we're just going to create a number array. And one thing to remember with the number array is that by default, it will create a class instance. So if you want the primitive array, you have to remember to always put the primitive prefix in front of it, otherwise you're going to get the class instances. But in some ways, So now let's use the map function, and in this case I'm just going to use a method reference to invoke this ×2 function over the collection. So if we open up the bytecode again, this is not exactly the most readable thing, so let's rewrite this a bit. Alright, that's a bit better. Alright, so what Kotlin's going to do is it's going to create a collections instance to capture all the values that we want to return from this collection. Now the problem with this is if you're working a lot in Dalvik, it means that it's going to auto box your entire primitive collection. So if you're working with primitive arrays and for some reason, be aware that the Kotlin extension functions for the collections will box everything for you. So it's just going to use a for loop to iterate everything and then add everything to the collection. If you really need to optimize it, you can use something like this, where you have to declare a Java interface because the Kotlin won't support SAM substitution for Kotlin interfaces yet. I think that's on the roadmap for maybe 1.3. And so we have to pass in our custom one because the map function here, is actually a generic. So because it's generic, it always has to upcast to a class type. So if we want to remain as a primitive, we have to do our own extension functions here. All right, so now what happens if we start chaining the functions together? Now I used to do C#, and I would expect this to, by default, be lazy, and then combine all the functions together. Unfortunately, we find that our filter function, when we look into the bytecode, is generating a for loop and then creating that intermediate collection. And then we see our map collection now here, and because it's created a generics collection intermediate object, we now have to use an iterate over the collection, so we can't use zero index lookups anymore. And so we have this double iteration. This isn't so much of a problem if you have a small collection of items. Maybe if you've got a few hundred or you're getting into the thousands, then this multiple iterations becomes actually noticeable in performance. But for smaller collections, it doesn't really matter. And if you're running on art and above, then your garbage collector is not going to be so much of a problem. But if you have to run on Dalvik, Yes, Dalvik, that's the name of it. I haven't used KiCad forever. Then you have to write your own extension functions and be careful about making sure that you're not auto-boxing where you don't expect it to be. And so the way in which we can get around this, if we want to collapse all the functions so they get kind of combined and we do a single pass, is to use a sequence. And this will combine all our functions together. So now we can see that it's just going to append all our functions. But unlike before, we don't have the ability of inlining. In fact, because the sequence is expecting a class reference, it's actually having to generate these anonymous inner classes for us and then pass that to the data structure. So if we go into this mapper1 function, we can see that it's actually extending this function reference class, which implements the function 1. Now this lambda here has 6 methods. So if you're really concerned about method count, try not to pass method references into or where something is expecting a class reference. So if we go through and have a look at some of the implementation for these functions, this is just a constructor, so this is just going to invoke the function reference, but it will pass the function reference an integer. And this integer is the function arity. And this is how Kotlin knows how many parameters it needs to pass to the function that you're trying to reference. So if we have a look at the synthetic bridge method, the reason we have the synthetic bridge is because Kotlin's function interface is generic, so it has to conform to type erasure. And in type erasure, the invoke function always has to accept an object and then return an object. So the synthetic bridge invokes responsibility is to unpack the object, cast it down, invoke the invoke, and then cast it back to the value, and then so that it can pass it back out. So its job is to mainly just invoke the actual implementation here, which is just calling the isEven method on our mapper class. And then finally, these last three functions, I can't find where they're actually being used. So it's possible that in this example here, that the method references don't need these reflection methods. And so, yeah, come back to me on that at some point once I work out what exactly is going on here. So this is fine if we have public methods that we're trying to reference. But what happens if we make them private? And so if we go back into our invoke function, we can see that we've actually now got these accessor methods that now have to be added to our mapper class. And so this implementation doesn't seem nearly as nice as it did before. And the way we get around this is by passing like just the normal Kotlin lambdas. So if we go into our mapper function here, we can see that the Kotlin lambdas are a lot slimmer in terms of method count. We only need 4 methods. And we've got a synthetic bridge in our invoke like we did before, and that's not really particularly too different. And then if you're actually looking for the bytecode, you'll find that you've got these outer class and inner class stuff. This is just metadata. For the most part, you can ignore this. This is just Kotlin marking where the lambda is used and where it's defined and tying those things together. So again, we have to pass the arity of the function to the lambda. And then if we go and look at our static constructor, so the static constructors, if you're not familiar with them, are invoked as soon as the class reference is loaded anywhere in the application. So as soon as you reference the outer class here, this method is going to be invoked and then construct the lambda ahead of time for us. So even though the lambda is not yet needed, the function will be created for us. And it will then cache it in this static instance variable. So now if we take our lambda class and then go back and look at our example as to how it's been used, we can see that it's not actually creating an instance lambda every time. So for the entire process of our application, we'll see that Kotlin will just reuse these static instances as soon as they've been loaded and keep them around for as long as possible. All right, so how can we reduce the method count even further? Because like 4 methods is great, but like Java 8 can do it with 1. So how close can we get to that number? So the first thing that we can probably get rid of is the synthetic bridge. And then the last thing that we can get rid of is the static constructor. So if you don't care about the function reuse, then you can actually get rid of it. And we'll have a look at how to do both these things in a second. So the first thing is we can use SAM functions to be able to get rid of that synthetic bridge. Because the synthetic bridge is created by the type erasure, so if we define the exact type, we can get around this problem. So probably the most canonical example is the the view on click listener. And so if we actually look at the lambda that we have here, we can see that this on-click listener is just going to be using the static constructor because we're not referencing anything from the enclosing activity. But we don't have an invoke or a synthetic bridge anymore, we just have the on-click. So now we're down to 3 methods. And so if we go into our on-click, in this case, there's not really particularly much happening here. Right, so now if we go and have a look as another case of lambda. So this lambda needs to be able to reference something in the enclosing class. So we need to capture that value. So if we actually open up the lambda here, we can see that we're passing in a reference to it, and that the invoke has to then access that lambda. But because we've declared it as private, we have a synthetic access that we need to get rid of. And so if we look in our lambda, we can see, sorry, I've named things in a very terrible manner. If we look in the LMDB class, we can see that we've got the synthetic accessor. And the way in which we can get rid of it is by marking the field as JVM protected. Now this is great until Kotlin starts complaining at you that protected is effectively final. And while this is technically true, I don't care. I would prefer to have that problem than have the synthetic accesses everywhere. But if you want to turn on warnings as errors in Kotlin, one of the ways in which you can do it is to suppress the protected and final. And this will turn off the error. And finding this exact string was actually quite hard. I actually downloaded the Kotlin compiler and then searched through all the error messages until I found this string. because these things just aren't documented anywhere. So if we now look in our invoke class, we can see that we don't actually have to reference their synthetic access anymore. We can just directly load the class and then invoke get the field and then invoke the property that we want on it. So data classes are great if you want to be able to have things like the two equals method and the toString and all that fun stuff. But we also get some really cool other things with it as well. So we get object destructuring, which is quite nice. And this is really, really helpful with pair, because if you need to return two things from something and then destructure it, it's really quite easy. And the way in which this is implemented is that Kotlin will generate these component 1, 2, and 3 functions. And so this is great, but the thing is, it's not the most strongly typed way of doing things. So if we get the order of the parameters wrong, there's nothing that actually stops it from failing the compiler. In fact, this example I have here, it will compile, there are no lint warnings, there's nothing. The only thing you get is an IntelliJ IDE inspection check. And the only way that you'd be able to run that on your CI server is to install Android Studio on your CI server and then call this shell script inside the build. And so, let's keep going. So the next thing in the data class is the copy constructor. And this is really great if you want to have the idea of like immutable records over time. So you want to just have a single record and you want to keep as many references live as possible and only change the things that are changing over time. But the copy constructor here doesn't have any kind of like overloads or anything. So to maintain compatibility with Java, how is it that we can have this in Kotlin but not actually pass in all the parameters? And the way in which this is done in Kotlin is that we actually will just load up the thing that we want to change, and then for everything else, we're just going to pass in null. And then we're just going to call this copy default constructor. But one of the things that you'll see if you're looking at the bytecode is that there's this bit push and null that's being passed that doesn't actually exist in our objects. And if we actually go into the copy constructor, we find this, but that's unreadable. Let's keep going. So if we convert it back into Java, we find something like this. So at the top of the function, we can see the object that we're passing in that we want to copy everything from, as well as all the optional properties that we're going to pass in. So in the bytecode, I've stripped out all the like not nullable stuff here. Sorry, the nullable stuff. So in this case, all these properties may not exist. And that's what those nulls that we're passing in before. But these last two properties, this hash and this arity marker, as far as I can tell, the arity marker doesn't really do anything. But the hash, talk about that. The hash actually tells the compiler, or tells us which property is actually changed. So in this case, the hash that we got was 6, and so we're going to bitwise and the hash with a bunch of generated properties. So in this case, the hash will only match the first property. So 6 and 1 will only ever equal 0. So we're only ever going to match on that first property. So then we copy description profile. Oh wait, no, which one did I pass in? Anyway, so the Kotlin will do the right thing, even though I've forgotten. Alright, so let's move on and look at statics. Alright, so if you declare a value inside just a file by itself, what that will compile out to is just it will take the name of the file that you referenced it from, and it will then create a private static final field. Again, these values will be initialized by the static constructor, so as soon as this file is referenced anywhere in your program, it will load up everything for you. This is probably the only time where it's possible to put something expensive into a static constructor, so try not to have static classes that do some type of I/O, because they will immediately be invoked as soon as the class is referenced. And so if we declare a function in a file, that's just going to, again, create a nice static function for us and just return it. If we declare a string, that is going to create a static function for us, sorry, static value for us, and then assign the string to it. But then we'll assign the string to it again in the static constructor. And it seems a bit wasteful to me. So the way in which you get around that is by assigning a const. And then it's just going to just inline it. So you won't have that double assignment. So this is probably not a problem unless you have a lot of like constants just hanging around somewhere. Okay, so let's have a few more, look at some more objects and statics. So we're going to have a look at like just a regular kind of object. So if you declare an object with nothing in it, it's just going to use the static constructor to initialize that object. If you declare like a val by itself, it will create the private final static. So unlike the file, it will be private by default, but it will also generate a getter for you. And again, it's going to do this double assignment unless we make it a const, and in which case we don't get that double assignment, and that the object will just have that instance class for it, and then just have the public final for us there. Now, if you declare a function inside of an object, you would think objects are static, right? So the functions are static, but they're not. The functions are attached to the instance object. So if you're using an object and you want the function to be static, we have to explicitly mark it as JVM static. And the reason for this is mostly due to compatibility with Java. As far as I can tell, I don't really know if there's any reason beyond that. Okay, so now let's start looking at the companion object. The companion object is probably the most complex thing in Kotlin, so if you've ever had problems with it, well, blame the Java anything. So we're just going to have a topic fragment here and a companion object. So if we look inside, we can see that we've got our public static companion, and then we've just got a regular constructor and our static constructor. So if we look inside the static constructor, we can see that we've got this companion object in it, and we're actually passing it this null value for this default constructor marker. And the default constructor marker is actually package private, so we can't actually create an instance of it. So we just have to pass null for it instead. And the reason for this is because the constructor for the companion object itself is actually private, so we need to invoke this synthetic constructor for it. I need to prove exactly why they're doing this, but I'm pretty sure it's to make it so that you can never actually instantiate a companion object yourself. And it's always going to be the compiler that's going to generate the bytecode to instantiate it. So one of the things that we need to do for fragments, we need to pass in extra properties. So if we put this property in here and then we just invoke it inside our init, if we actually go and look in the bytecode, we can see, okay, cool, so we've got a private static here. We didn't declare it as private, so why is it private? And so let's keep looking. So if we look in the static constructor, we can see that we're assigning the static. So again, we get that double assignment because we didn't make it a const. And then if we look inside the constructor, we can see that the constructor is actually calling the companion object to get the instance of the topic ID. And this is true in Android 1.2.31 and below. This is actually being fixed in the latest release, which came out like 5 days ago. So if you haven't upgraded, probably do it. And so that's great. But what happens if we refer to it inside the companion object? And if we actually have a look in the companion object, we can see that we're calling another getter again. And this getter is actually calling a synthetic accessor on the topic objects, because the companion object will always try to inline primitives into its enclosing parent. So it doesn't actually have access to the value that you've declared inside it. So we actually need to go to the parent to be able to get the accessor to get it. And so this was way more complex than what in this version of Kotlin. So this is like the access diagram for what you had to do to like access these constants that you've defined. And so the way to get rid of all this nonsense is to really just define it as a const. So if we could go back into the bytecode, we can see now it's been declared as a public. If you do mark it as private in the companion objects, it will inline it as a private static final in the enclosing class. So what are some of the other cases that we need to be careful of in the companion object? So one of the other things you need to be careful of is remember that when you've declared like non-constants in the companion object, the way in which they get treated and where they get placed ends up being really, really weird. So in this case, we've got, so we have to have a synthetic accessor again for our format function here. So we can see that our parseDate function has to go to our enclosing class to be able to get the value that we declared in the companion. And so this isn't particularly the nicest thing to do. So how do we solve this problem? Well, one of the things that we can use is we can use the fact that any file private class becomes package private. So we can declare like a format companion object. So our companion needs a companion to be able to have values that our companion can access. So if we declare it as a private object in the same file, and then we go back and look at it, we can see that we're now just calling the static on our companion's companion, which is a lot nicer than what we had before. So this removes a lot of the access methods that you tend to run into. Yeah, so if you make it a constant, then any kind of constant you have the Kotlin compiler will just inline the value into it. So if you can't make something a constant, try not putting it in the companion object, otherwise you will get these synthetic accesses that you just don't expect to be there. Alright, so how do we start to use some of this scoping to reduce synthetic methods? So one of the things to be careful of is if you're using something like lazy. The lazy delegate actually requires a class to be implemented. So if the lazy delegate here is accessing our repository and our scheduler, to be able to actually implement this, we actually have to generate synthetic accesses to be able to access them, because lazy is another class and Java bytecode doesn't actually support inner classes. So the compiler will generate these synthetic accesses for us. Now, if you remember the example from before, we just need to, again, mark it as JVM field and protected. And then we can use suppress, protected, and final, and this can be applied to the entire class. So we can now apply this to an entire class. We don't have to add it to every field or everything in our class. And this removes a lot of methods for us. And finally, let's look at some async stuff. So the async is really interesting in how it's actually implemented. So we're just going to have this simple kind of suspended function, which is just going to wait for X amount of time and then just return the time that we told it to wait for. And so the way in which Kotlin does this is it passes this continuation object into it every time. And this is the object that allows us to kind of resume the place in the code that we were when we suspended the execution. So if we go into the object here, we can see that every time we call the wait for, it's going to check, that font comes out terribly. It's going to check that we have the instance we want. If it's not, it's going to jump. It's just going to check to see that we're in the right state. If it's not, it's going to jump. And it's going to check to see where we are if we're resuming the function, and then jump again. And if we actually look at what it's doing, the first two states are for when the function is being called for the first time. And so we just want to new up the state machine, which is going to keep track of where everything is in our execution. And then if we haven't executed before, we want to get the suspended coroutine and then continue it. So we just want to resume the state machine. So if we go look at the L2 label, this is the thing where the state machine then jumps to once it's ready to resume. And so it uses integers to tell it where it was last in the execution, and then these labels will then tell us which label blocks to then invoke. So if the last thing that was invoked was 0, we will jump to L3. And L3 says, just check the state of the state machine. If it's in an invalid state, then throw. Otherwise, we want to invoke the delay function, which will then wait and then call back the state machine that we just invoked. Now, if we go back to here, so if, we then jump to L4. So L4 is going to, in this case, is just going to check the state of our state machine from what I remember. And then finally, provided our state machine is still in a valid state, we're just going to evoke the next line. And so that's really a kind of sample of all the things you can see in bytecode. If you want to be able to start inspecting the bytecode to see what's going on behind the hood, I recommend opening up the bytecode viewer. Don't be afraid of the bytecode. Most of the things in there are just kind of stack management for the JVM. So JVM is a stack-based virtual machine. So for the most part, you can ignore pretty much all of the A loads and A stores because they're just dealing with the state management. So if you want to, you can copy out the bytecode into a text file and just strip all that stuff out, and you actually get an idea about what it's doing. Trying to read if checks is a bit tricky because there is no indentation in the bytecode, so the ifs tend to just use jump blocks. And if the if fails, it will continue executing until it finds another jump block. If it passes, it will execute the jump block, which is to the right of the if statement. So it can take a little bit to kind of get used to. Some of the primitives have odd symbols that you wouldn't expect, like a long is actually marked as a J because it's, L is already taken because L is used to reference type classes. The other thing that you can use is the bytecode viewer. So this is good if you need to be able to open up some Java files and see what's going on inside there. And that's it. So that's really some of the most interesting things I found in the Kotlin bytecode. There's lots of other stuff in there as well. But for the most part, Kotlin does a fairly good job of doing the right thing. I would say some of the things that it doesn't quite get right is probably like some of the weird things you have to do to get the access scopes that you want. So you really have to use those annotations and kind of suppress warnings that the Kotlin compiler would normally give you. But yeah, so I'm Mitchell Tilbrook. If you ever have any questions, yep.
So listening through your talk, I wasn't sure whether you really love Kotlin or really hate Kotlin. I'm serious, like you went so deep and so far into some aspects of the code that you presented that I wasn't sure where you are. And you also showed a few things which are borderline worrying whether they should be used or not. I mean, in the way that Kotlin compiles to bytecode.
Yeah.
And
can I answer the first two questions?
Sure.
So the first question was, do I love or hate Kotlin? Love and hate are the same coin, and I love to spend Kotlin coins.
Okay.
So I think it's important to understand what's happening, especially when you're programming for Android. Some of the newer devices are a little bit nicer in that we've got art, but if you have to go all the way back to Dalvik, you definitely have to be aware about certain things that Kotlin is doing. So Kotlin is not written for Android, it was written for JetBrains so they could backport features to Java 6 because their customers wouldn't upgrade. Can you repeat the second question?
I was actually getting to that.
Oh, sorry, yeah.
That was my second question. How much in-depth knowledge do you need to have? Like when you do a code review, which is, let's say, a few hundred lines,
yeah.
It might be easy to keep context. If you're doing a bigger code review or multiple code reviews per day, you can't have all of this in scope in your head all the time, plus all the other stuff that you probably do have in your head. while looking line per line on every line of code that you go through a code review, or even when you write it yourself. And maybe it's even different for versions of Kotlin, for compilers. What is right today will not be right tomorrow.
Yeah, so
how do you manage this? What I do know, what I expect to have happened, what people wrote.
Yeah.
In
all right, let me try and paraphrase that for the recording. So the question is like, how do you keep all this kind of in-depth knowledge in your head, and how do you share it amongst your colleagues? And I would say, don't find some way to automate this into the tooling. So if you can, there's a project called KTlint, which allows you to take abstract syntax trees, and then you can write rules for that, which you can put into like your CI, which will tell you when you're using a private field, which can be marked as a JVM field, protected, and then suppress the warning. Yeah, so basically, yeah, you really want to find some way to put it into a linter that you can run as a check, because you don't want to have to keep all this stuff in your head all the time, because even I forget some of these rules sometimes. I'll go back, look at my code, I'm like, oh, who forgot to put this here? And I go get blamed, it's like, oh, it's me.
Yeah, I mean, definitely you cannot have this context all the time.
No, especially in Android, there are so many rules and exceptions to things that you really want that automated tooling to remind you of things, so you don't have to constantly think about this. Because what really matters to your business is delivering that feature, not getting rid of synthetic accesses. Anyone else? All right. Well, I'll be around if you want to ask any questions or diving deeper into the code. I've spent a long time just looking at the bytecode, trying to work out how things are working. Thank you very much.